Today, we're going to pull back the curtain on the invisible architecture that runs pretty much everything we use. It's called Object-Oriented Design, or OOD, and it's the big idea that keeps all of our modern software from just, well, collapsing into total chaos.
I mean, it's just a fact, right? Software runs our phones, our cars, our banks, you name it. It's literally woven into the fabric of our lives.
And here's the catch. As these systems get bigger, they get exponentially harder to manage. You make one tiny change over here, and suddenly something completely unrelated breaks over there.
So how in the world do developers build these massive, globe-spanning applications without them turning into an unmanageable mess? That's the big question, and that's exactly what we're going to answer in this explainer.
To really get why object-oriented design was such a game-changer, you've got to see the kind of chaos it was born from. Let's take a quick look at the problem it was built to solve.
So, in the old days of programming, you had your data over here and the functions that used it way over there. They were completely separate. And a lot of that data was just out in the open, what we call global. This meant any part of the program could reach in and change it at any time. It was a debugging nightmare because you could never be sure what was changing your data or when.
And then came the solution, object-oriented design. Instead of having data and functions all over the place, OOD had this really simple but powerful idea. Why not bundle the data and the functions that work on it into one self-contained little package? And just like that, this simple shift brought order and predictability to all that chaos.
So, what's at the heart of this revolutionary idea? It really all comes down to learning how to think in objects.
So, an object is basically a building block that mirrors a thing from the real world. Think of an employee object in a company's HR software. It holds its own data, like a name and a salary, and it has its own behaviors, like a function to calculate a bonus or update an address. The key thing is the data and the behavior are locked in together.
Okay, so if the object is the finished house, then the class is the architect's blueprint for that house. You design the employee class just once, spelling out all the data and behaviors it should have, and then, bam, you can create thousands of individual employee objects from that single blueprint.
And this ice cream example just makes it so clear, doesn't it? The data, we call them attributes, are things like flavor and num scoops. And the behaviors, we call them methods, are actions like scoop or total_cost. It's a perfect, neat little model of a real thing all bundled up.
Now, this whole object-oriented way of thinking is held up by four incredibly powerful principles. People often call them the 4 pillars, and together, they are the secret sauce for taming software complexity.
The first pillar is encapsulation. Think about a toaster. To make toast, all you need to do is interact with one simple thing, the lever. That's its public interface. You don't need to know anything about the private stuff inside, the heating coils, the timer, none of it. Encapsulation is just like that. It hides all the messy internal details of an object and just gives you a simple, clean interface to work with.
Next up is abstraction, which is a very close cousin to encapsulation. The steering wheel in your car? That is a perfect abstraction. It gives you a super simple way to control a really complex system. The engine, the axles, the whole shebang. You don't need to know how it all works, you just need to know that turning the wheel turns the car. Abstraction is all about showing you only the essential controls and hiding everything else.
Our third pillar, inheritance, is an amazing tool for reusing code. It's all based on what we call an is-a relationship. So instead of building every single thing from scratch, you create a general blueprint, and then more specific blueprints can just, well, inherit its features, adding only the new stuff that makes them unique.
This is the perfect example. A car is a vehicle. A motorcycle also is a vehicle. So they both inherit the common stuff from the vehicle class, like a start method. But then the car can add its own unique behavior, like open door, which, a motorcycle doesn't have. This is how developers avoid writing the same code over and over again. It's super efficient.
And finally, we have polymorphism. It's a fancy Greek word that literally means many forms. And what it lets us do is write way more flexible code. For instance, you could have a single command like process payment. A credit card object and a PayPal object can both respond to that same command, but each one will handle it in its own special way. So how do these 4 pillars all come together to create a real design philosophy? Let's look at the one big principle that really ties it all together and helps developers build systems that are both stable and flexible.
It all boils down to this one crucial idea.
This is where you really see the power of those 4 pillars at work. It means your code should rely on the abstract, stable parts of your objects, like the steering wheel, not the messy, constantly changing internal details, like the specific parts of the engine.
And this diagram shows you exactly why that's so powerful. You see the high-level policy at the top? That's the main logic of your app. It doesn't talk directly to the messy, detailed implementation at the bottom. No way. Instead, it connects to that stable middle layer of abstract interfaces. What this means is you can totally change or update the details down below, and as long as you don't break that interface contract, the main application doesn't even notice. It's incredibly resilient.
Okay, I know. We've gone through a lot of pretty abstract concepts here. But why should you actually care about any of this? What's the real-world payoff? Well, at the end of the day, the payoff is huge. Object-oriented design lets developers build software that is just dramatically easier to manage in the long run. You can reuse code instead of rewriting it. You can add new features without creating a domino effect of bugs. And when bugs do pop up, they're so much easier to find and fix because the problem is usually trapped inside one single object.
Honestly, from your phone's operating system to the massive web services that power your online shopping and social media, these principles of object-oriented design are what make it all work. They're the secret to building systems that can grow and change without collapsing under their own weight.
And that brings us to the end. But I want to leave you with one final thought. This way of thinking, it's not just for software. What if you started to model complex, real-world systems, like a city's traffic grid or a hospital's patient flow, as a collection of interacting objects? What kinds of elegant, powerful solutions might you come up with then? Something to think about. Thanks for joining me.